So now in this video, we have an NPN bipolar junction transistor. I'm using the 2N3904, but if it's pin or if it's part number, starts with 2N and it's a bipolar junction transistor. There's other components that start with 2N. But in any case, if it's a bipolar junction transistor, you can pretty much expect left pin when you're looking at the front. Left pin is the emitter, middle pin is the base, and right pin is the collector. Now, if the bipolar junction transistor, you look it up on a data sheet, the part number, and see it's a bipolar junction transistor. But if it doesn't start with 2N, it may have a different pin layout. So for the C945 right there, I got emitter, collector, and then base. Base is off to the side right there. So it looks like they swapped the base and the collector for that one. So it's pretty easy to figure out when you have the base in the wrong spot. But if there's collector and emitter and collector, however you want to look at it, at both ends, it's really easy to put it in backwards. They're both N-type material, and at lower voltages, the transistor might work perfectly fine. So one thing to remember, with a diode, you make the P-type material more positive, N-type material more negative, current flows. And so when it comes to NPN, bipolar junction transistors, we got the positive supply there, negative supply down here, and thus when we got negative, that holds it off. If we get positive over here, we get a little bit of current flow. That's PN right there, more positive, current flows a little bit. And the NPN bipolar junction transistor will still work like that if you put it in backwards for turning on. And at lower voltages, it will even turn off. So at 5 volts, we probably won't notice any difference with this circuit being the wrong way. It's at higher voltages where we will have the problem. So I wrote these numbers here. I made this diagram a long time ago, and in any case, I looked at the data sheet, so I assume it's right, but always check the data sheet yourself. So we got the voltage, and that is the collector to emitter open circuit, I think it would be. That means that it's not conducting. So, you know, when it's conducting, it's going to drop the voltage that's across it. So when it's off, open, you can put up to about 40 volts approximately right there. And then there's some other voltages here. The one right here is emitter to base. So that's backwards. You can see it says 6 volts. So that's if you put it in backwards, you'd have the more positive going to the emitter. And then the base, if you connect it to ground, you can expect some conduction right there. And once you get a little bit of conduction in one part, the whole thing is going to conduct basically, as long as you have positive and negative in all the right spots. So we're not going to worry about that too much. But the C945, again, it has a different pin layout, but the rules, you know, are the same. Looks like it can handle more voltage than the 2N3904 when it is off. And less voltage here, collector to emitter open voltage. So yeah, that's kind of interesting. So looks like this might not fail as often with staying off, but it can't handle as much voltage. Okay, so we're not going to worry about that though. The main takeaway is that you can, you know, learn more about that. Check in data sheets and stuff, and you can do like your own tests. But with high voltage, you are going to fry transistors if you wire them up wrong. And maybe that's your goal. See where their limit is. Hopefully it'll do better than the data sheet said so. But yeah, in any case, we're back here. Showed the circuit on the schematic that we got here. Just a, you know, bipolar junction transistor, which would be a switch if you could bounce back and forth from positive to negative with something, you know. But we're going to go to negative and keep it at negative. First thing we're going to do is put the transistor back. So you can see we're at 5 volts, and I'm going to put the transistor the wrong way. So that's collector, base, emitter. So you can see there, emitter is to the left. It was to the bottom. Now I keep swiveling it. The emitter is on top. It is to that jumper there. And then we got the base and the collector. So now we will zoom back and look at, we got 5 volts right there. And I'm going to raise this, so it should be trying to hold it off right there. But yeah, I noticed somewhere around 12 volts we get a little bit of glow, and then 13, 14, 15. So it's conducting the way it's not supposed to. I don't think we're doing any damage. You know, it's not good to put it backwards, but you know, I do this every once in a while, and the transistors don't seem to be like fried or anything. Of course, if I keep going up in voltage, we're going to get more current to flow through. So again, I got it in backwards, and we don't need to look at the power supply. Hopefully this isn't getting too hot, because I'm going to actually touch it. So yeah, we got flat side to the left right now, but the middle pin is base. We know that, and this is to ground. It should not be on, you know. And so we plug this out, turn it around. You know, it's a little bit warm. Maybe it would get hot over time. But there we go. Now I got it in the right way. We got the emitter to the load, collector to the positive supply. We could probably go up to 40 volts right now, and it will still stay off. So I feel so safe about that. This power supply doesn't go to 40 volts, but it does go to 30 volts, and it's still off. If I swivel it around now, we'll probably fry something or shorten the life of something. But this should definitely stay off at 30 volts. I believe 40 volts is the maximum that they suggest that you do. You shouldn't aim for 40 volts. You know, maybe like keep this to like 20 volt circuits or something. A safe range. You don't want to push the limits of electrical components. It shortens their life. Whether or not they do a good job at the time that you do it. The more you push them to their limits, the quicker they burn out. So, in any case, yeah, that was it. We will come back to the diagram right there. So, when P-type material, more positive and negative, it conducts. This is not like a measuring or something. I just wanted to say that's more red for positive, that's more blue for negative. Whereas if you make the P-type material more negative, apply negative voltage there, a positive voltage to that side, it doesn't conduct. You know, basic diode stuff. There's one way you can look at it. There's a couple of diodes there, but when it comes to the whole component, a little bit of current flowing either that way or that way will allow a lot more current to flow through the whole unit. But the voltages that it can handle does make a difference. The base to emitter, if this is the emitter there, is weaker when it comes to voltage being the wrong way than the collector to emitter. So that's why it can stay off when the positive side is to the collector, but not when it is to the emitter if the voltage gets high enough. So, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.